In this video, we're going to talk about how to algebraically isolate variables and combine gas law problems. First, as you're reading the problem, take note of key units and key values in the problem. So right here, this 12 atmospheres is pressure. And this 23 liters, well, that's volume. The 200 Kelvin, that's temperature. And the 14 atmospheres, that's pressure. And the 300 Kelvin, that's temperature. Since this problem involves going from one situation to a new situation, we're going to use the combined gas law. All right, so that's going to be P1 V1 over T1 equals P2 V2 over T2. Make sure that when you're doing these gas law problems that you have consistency in your units. So see, we have atmospheres, liters, and Kelvin. All right, so we want to also make sure that we have atmospheres, liters, and Kelvin. And in this particular problem, we're solving for volume, so that'll end up being in liters. If you have consistency in your units, like in this problem, then you can leave all your units out of the problem. So here, P1 is 12, V1 is 23, T1 is 200, P2 is 14, V2 is question mark, and T2 is 300. If you want to make things less confusing, rewrite just the letters and get the yellow by itself. P1 V1 over T1 equals P2 V2 over T2. How do you get V2 by itself? So multiply both sides by T2 times T2 over 1. And then over here, times T2 over 1. The reason why you want to multiply it on both sides, like on top, like that, is because you can diagonally wipe it out right here. All right, now we're going to rewrite it. So we're going to get P2, V2, the bottom is gone now, because it's just that times nothing times 1, equals, right, and you can leave the over 1 out. So you can have T2 times P1, I can put the times there, times V1 over T1. But we're still solving for V2, right? All right, so we still got to get this V2 right here by itself. Watch, if I were to go over here, and I said, all right, you got 12 equals 17x. So you know over here how you go like divide by 17? Boom. And you go divide by 17 like that. Now we're going to do something similar, but we're going to multiply on both sides instead of divide. Let's say you have 12 over like 30 equals 7x. Multiply both sides by 1 over 7. Now, what's going to happen on the right? And what's going to happen on the left? All of this, I'm going to rewrite it down here. Now, it's 1 times 12 over 7 times 30. So here, you can still put it over 1 right here. Now multiply 1 over P2 on both sides. Now let's rewrite what we have, and notice that we've completely isolated V2 because these wipe. So V2 equals T2 times P1 times V2 all over P2 times T1. Now let's say you have P1 V1 T1 equals P2 V2 T2. Let's say I have to isolate T2 actually. So if you need to isolate T2, it means you got to bring it on top. In order to bring it on top, you need to multiply it to both sides. Whenever you do something on one side, the other side has to look exactly like it. So that's gone right there. Let's just write it a little prettier. And we're trying to get T2, right? So get rid of your fraction. You have to get rid of the fraction first before you can move the other ones. Before you move those, you got to get rid of that. So times T1 over 1 times T1 over 1. Cancels. T2 P1 V1 equals P2 times V2 times T1.
Okay, and remember, we're trying to get T2 by itself. So now divide the left side by P1 V1 and divide the right side by P1 V1. And on the left, P1 times V1 cancel out. And you're left with T2 equals P2 times V2 times T1 over P1 times V1.